Dear students, greetings for the day. In the previous class, let us discuss the introduction of the friction part. Now let us recapitulate the topics discussed in the previous chapter. When two bodies are in contact, then there exists a opposing force to their relative motion called frictional force or simply called friction. So friction is a force which opposes the relative motion between the two bodies in motion. The causes of friction. There are three causes for friction. First one is molecular adhesion. The attraction forces between the molecules of the two surfaces in contact is known as molecular adhesion. There are cohesive forces and attraction forces between the two surfaces in contact. When same type of surfaces are in contact, then attraction forces of cohesion are acting between the two surfaces. If there are two different material surfaces are in contact, then the attraction forces of adhesion are acting between the two surfaces in contact. Second cause is surface roughness. Even though surfaces seems to be smooth, when we observe through the microscope, they have ups and downs like hills and downs, causing the opposition to the relative motion between the two surfaces in contact. Next, friction is also depends upon the nature of the materials in contact. And third one, surface deformation. When the surfaces are in contact, the surface undergo deformation, which produces friction between the two surfaces in contact for their relative motion. And fourth one, nature of materials in contact. So these are the causes of friction. Now we discuss the factors affecting the friction. Materials, so the nature of materials in contact affects the friction. Second one, surface finishing. So when the surfaces are rough, then if we finish smooth, then it affects the friction value. Third one, temperature of the surfaces. Fourth factor affecting the friction is impurities in the surfaces. one, lubrication of the surfaces. Sixth one, factor affecting the friction is normal force. Pressing the two surfaces. So these are the factors affecting the friction. Next, let us again recapitulate the types of friction. There are four types of friction. First one is static friction or limiting friction. Second one is kinetic friction or sliding friction. Third one, rolling friction. Fourth one, fluid friction. It is air friction. So when the two bodies are in contact, when one body rests on the surface of the another body, then there exists a force which comes into play, which opposes the relative motion between the two bodies in contact, is known as static friction. The maximum value of static friction is known as limiting friction. It is denoted by F bar. Yes, here it is denoted by sometimes Fs or Fl. Kinetic friction comes into play when one body moves on the surface of another body. It is generally denoted by F bar K. Rolling friction comes into play when one body rolls on the surface of another body. It is denoted by F R. And fluid friction means air friction, which is observed in the cases when the body is traveling in the air, that is when aeroplane or automobiles moving in air, and air friction is observed. So by streamlining the shape of the automobiles, we can decrease the air friction. And in water, fishes and birds are having special shapes to reduce the water friction, fluid friction. Now let us go through the expression for. Now we again recapitulate the advantages of friction. Friction is a necessary force in our daily life. Without friction, we can't live. So, we can hold objects with our fingers due to friction. Nails hold to the wall due to friction only. matchstick is lighted due to friction, and we can walk on the ground on our foot due to the presence of friction only. So the friction is a necessary force in our daily life, and we again recapitulate the disadvantages of friction. Due to friction, wear and tear of the machinery parts caused, and nearly 30% of electrical energy is wasted to overcome the friction. And due to friction, heat is produced between the rotatory parts of the machine, and wear and tear of the machinery parts is caused. And we already discussed the methods of reducing friction. To reduce friction, polishing should be done. Even though seems to be surfaces are smooth, by polishing we can reduce the friction. And also by using anti-friction metals like steel, we can reduce the friction between the rotating parts. By using oils and grease between the rotatory parts, we can reduce friction. By using ball bearings in fans, rotatory parts of the machinery, we can reduce friction. And also by streamlining the shape of the automobiles, we can reduce fluid friction, that is air friction. These are the topics discussed in the previous class. Now we derive the expression for static frictional force. So as per the laws of friction, static frictional force is directly proportional to the normal reaction N bar or R bar. So if we remove this proportionality constant, F bar is equal to some proportionality constant mu s into R bar. So from this we can write mu s is equal to Fs by R. So here proportionality constant mu s is known as coefficient of static friction. Similarly, in the case of limiting friction, Fs maximum is equal to mu L into R bar, or mu L is equal to Fs maximum by R bar. So maximum value of friction is 1 and minimum value of friction is 0. When the surfaces are smooth, then frictional value is 0. Now similarly, in case of kinetic friction, the frictional force present between the two surfaces in contact is directly proportional to R bar, or Fk is equal to kinetic frictional force F bar K is directly proportional to R bar, normal reaction force, or F bar K is equal to proportional to constant mu K into R bar, or coefficient of static friction, kinetic friction is F bar K by R. So when two bodies are in contact and when one body moves on the surface of another body, then kinetic friction comes into play. So coefficient of kinetic friction is given by the F bar K by R bar. When one body rolls on the surface of another body, then the frictional force which comes into play is known as rolling friction, and it is proportional to the normal reaction So F bar Rho is equal to proportionality constant mu Rho into R bar. Here proportionality constant mu Rho is called coefficient of rolling friction, whose value is given by F bar Rho by R bar. So in this case, here when compared, static friction is more than kinetic friction, which is more than rolling friction. This may be written like this also. F bar Rho is less than kinetic friction, which is less than static friction, limiting friction. And similarly, coefficient of static friction is greater than coefficient of kinetic friction, which is greater than coefficient of rolling friction. Rolling friction coefficient is less than the kinetic friction coefficient, and which is less than the static coefficient of static friction. Now we know about the angle of friction. When the body lies on the horizontal surface, consider a body of mass m lies on the horizontal surface, and its weight acts vertically downward, which is balanced by the normal reaction force R bar or M bar is equal to mg. Now when when force is applied, the body moves towards the right direction, then force of friction acts in this direction, left side, towards the contacting side, along the line of contacting surface actually. So the resultant of force of friction and normal reaction is given by like this, and the angle between the resultant of force of friction and the normal reaction, and the normal reaction is called angle of friction. So angle of friction is the angle made by the resultant of kinetic frictional force and normal reaction with the normal reaction. So from this figure, tan theta is equal to QR by RFS by R bar. So tan theta is equal to, which is equal to static friction. Therefore, this is the relation between the angle of friction and the coefficient of static friction. Now we derive the expression for force acting on the body and acceleration produced in the body when the body lying on the horizontal surface. consider a body of mass m which lies on the surface of the body at its weight acts vertically downwards, and a normal force acting perpendicular to the surface, and it is exerted by the body by the surface. R bar or N bar is equal to mg weight. Now, when force is applied towards right, then friction acts vertical towards the left, force of friction. Like this, along the line of contact. Now the normal reaction R bar is balanced by the weight of the body mg. Therefore, force of friction is F bar K is proportional to R bar, or F bar K is equal to mu K into R bar. Since R is equal to mg, F bar K is equal to, as there is if there is no force, F bar K is equal to mu g. This is equal to the resultant force. Therefore, resultant force on the body acting on the body is mu K mg. Similarly, acceleration of the body, acceleration acting on the body, acceleration of the body Fk by m, or mu K mg by m, that equal to mu kg, or this is the actually retardation. Retardation of the body is mu kg, or acceleration equal to minus mu kg. Now derive expressions for displacement. Due to the retardation produced in the body mu kg, the body moves through some distance and it stops after traveling certain distance s. Calculate the expression for displacement. From the figure, initial velocity is u, and final velocity is 0 after time. Distance traveled is let it be s equal to s, and acceleration produced in the body is already we derived in the previous expression, minus mu kg. So from the equation v square minus u square equal to 2as v value 0 square minus u square is equal to 2 into minus mu kg into s, or we want the value of s displacement, s equal to u square by 2 mu k. This is the expression for displacement, s equal to u square by 2 mu k g. Now we derive expression for time taken by the body to come to rest. Now we derive the expression for it. So here initial velocity of the body is u equal to u, and final velocity v equal to 0, a equal to minus mu k g. Let time taken to come to rest, let it be time t. Now from the equation v equal to u plus at, from equation of motion v equal to u plus at, v is 0, u is u, plus a value minus mu k g into t. So it implies mu k g t is equal to u, or time taken to come to rest is u by mu k into g k. This is the expression for time taken to come to rest by the body after coming to rest. Now we then derive the expression for work done by the body before coming to rest. Body is coming to rest. So we know that work is the scalar product of force and displacement. So here work done is so F is mu k mg into displacement is s. So this is the expression for work done by the body before coming to rest. Now we shall do the some problems on these topics. Consider a body of mass 10 kg is moving on a rough horizontal surface. Find the force required by the body if coefficient of friction is 0.5 and G equal to acceleration due to gravity, G is equal to 9.8 meter per second square. So here mass is given that mass is 10 kg. Mu equal to 0.5, G equal to 9.8 meter per second square. What is the expression for force? Force required by the body mu k mg. That is mu k is 0.5, mu is 10, g is 9.8. That equal to 49 newtons.